So, a little bit of history. As I said, we had presented probably a couple of years ago. I remember, we did that when Steve was there, and we'd given an overview of the company, our value proposition, et cetera. So I was going to take you back a bit and give you a sense of where we've come from and so give you a brief history of it. So Tegile as a company was founded back in 2010. We started shipping arrays back in 2012. We had our first 50 customers in 2012. Rapidly introduced an all-flash product line back in 2014. About 1,000 arrays shipped by that time. We made it to the Gartner MQ, both for general purpose data arrays as well as the AFA MQ as visionaries. Since then, we introduced what we call our high-density flash arrays. So these are multi-tiered flash arrays that take two different types of media into the environment. And then we'll go into the details of how our product is unique enough to take advantage of the different types of media. In 2016, we had our Rev 2 of that version to get to substantially higher densities. So for example, today we can ship in a 5U box a petabyte worth of all flash, right? Which has different tiers and layers of it. We introduced our NVMe all-flash arrays back in 2017 at VMworld, so August, September of 2017. Right when we had introduced, and we were right in the midst of VMworld, Western Digital acquired us. So we became part of Western Digital Data Center Systems, as Phil said. And then, if you look back at our history, obviously we started off as a hybrid company and then substantially sort of grown our business. That today, as we stand, i.e. in early 2018, more than 60% of our revenue is coming from all-flash. And you'll see that from an architectural standpoint, how we are differentiated, and I'll go into some of the details of that as to how we've been able to sort of start off as a hybrid storage company and then evolved into an all-flash company. So as we stand today, we have about 2,000 plus customers, about 3,000 plus systems in production. Okay? So that's your brief history. So let me dive into the details of IntelliFlash. So one of the core value propositions for us is we wanted to, in fact, we go back in history and says, what was one of our design principles? Our design principles was that we want to deliver an enterprise class storage system that is able to take advantage of different media types. So we all know that we see a plethora of different applications in the environment. Each application dictates a certain performance at an economic level. And the question is, can you have an enterprise storage system that can take advantage of the different media types to be able to deliver performance and economics at the right, for the right set of applications. So we introduced our platform, which is a unified storage platform. In other words, I can do block and file natively in the system. And one of the core design principles was, how do we take advantage of this evolution of media types? Because we do know that if you go back in history, hard disk drives have been around. We saw the first emergence of flash, obviously SLC, and then subsequently we started to see emergence of MLC, more economical flash. So the core design point for us was, how do we design a system that's going to be able to take advantage of the different media types without having to go change infrastructure? So whether you are deploying a hybrid system or in the future all flash or even all NVMe flash, we wanted to have a system that will do that. So our systems today essentially run one operating environment. Unlike many of our competitors who have legacy systems, hybrid systems that are distinct from all-flash systems, our systems run one single operating environment. And based on your needs, you can dial up or down flash to be able to hit the specific economic cost point and performance points. So on the one end of the spectrum, you've got a hybrid system that has 10% flash. And the other end of the spectrum, you've got NVMe, which has 100% flash, and then various grades of various ratios of flash to spinning media. If you look at each of our systems, whether it's the hybrid or flash hybrid or all flash, our design is such that all of the I/O comes into the flash layer. So even in a hybrid context, you see sub-millisecond performance. The other 2 points that we wanted to ensure as part of our design evolution was we want to have one feature set, which means if I can snapshot, clone, replicate, thin provision, et cetera, it'll work seamlessly across whether it's hybrid or NVMe flash on the other end of the spectrum. So we wanted to give just the customers one user experience so that they learn one set of tools. And we've been able to do that very effectively. So what does our portfolio look like? Just sort of building on that theme, on the one end of the spectrum, you've got hybrid arrays all the way up to NVMe arrays. And we also have a converged design infrastructure designed with Cisco and other, Dell as a server class. So we qualified, servers, networking, and storage. So one operating system that runs our clusters. So you see hybrid arrays, all flash arrays. You get multi-tiered flash arrays, which have multiple different grades of media, and then NVMe flash arrays. So that's our portfolio today. So how do these things map into the various different workloads as you would expect? So broadly speaking, I'm looking at it very simplistically, which is, greater than 1 to 2 millisecond, greater than 1 millisecond, and then sub-millisecond latency, right? So this is how our platforms fill in. The T-Series flash hybrid configurations are targeted at 1 to 2 milliseconds, along with the hybrid storage. For the all-flash and multi-tiered flash, we see our T-Series and HD series in the 1 millisecond range. And then our N-series storage, which is the NVMe storage, which is targeted at sub-millisecond.
So, Narayan,
yes.
The block storage is fiber channel or iSCSI?
Great. So the answer is yes. So in terms of the portfolio of capabilities, it includes block, which is fiber channel and iSCSI, file, which is NFS and SMB3. So all of that in the same platform running concurrently.
And the NVMe storage solutions are fiber channel connected?
Yes. So today, the NVMe storage system uses NVMe drives behind a set of controllers, and we're making data available over these protocols, which is block
fiber
and
channel,
file.
Yeah.
And our expectation is, as the market space evolves, we will actually provide NVMe target out of the box itself. Right.
And the tiered flash is got like SLC, MLC,
yes.
TLC.
So if you go back in history, the tiered flash systems essentially had SLC plus enterprise MLC. We've sort of grown up from that because you don't find SLC drives anymore. So for the most part, we use today as it ships a combination of NVMe drives along with enterprise MLC. Right? So as we see the evolution going forward, we see eMLC will probably give way to sort of QLC in the future, right? And the essential idea is to deliver on the performance and economic cost points that are required of different applications. So broadly speaking, this is where we see success today, which is our NVMe systems are obviously targeted at low latency apps. The classic all-flash arrays are targeted at what I call high IOPS applications as well as virtual infrastructure applications. So the typical ones you would see are virtual servers, desktop virtualization, build and test. And then our hybrid systems are targeted now at more of secondary storage applications. So one of the unique things, as I said, was since we have a single operating environment, I can replicate from one high-performance NVMe system to a secondary storage system, which is a hybrid system, and I can go back and forth. So that is a value proposition which has helped us sort of garner north of 2,000 customers today. Okay, so diving a little bit deeper, what does IntelliFlash operating system provide? As you would expect, we're playing in the enterprise storage space. We've got the plethora of capabilities. So whether it's instant snapshots, clones, inline compression, dedupe, asynchronous replication, end-to-end data integrity, pick your favorite. I got everything there. Right? So, and we're seeing success in a variety of different application environments, right? Whether it's over block or file, and actually a combination of that. Okay, so diving a little deeper. So how do we look at IntelliFlash, right? So broadly speaking, again, a little bit of a architecture slide. We have this physical media. We'll go into the details of what optimizations we have done to take advantage of the different media types. One of the core areas where we've spent a substantial amount of our R&D investments is in the areas of metadata classification and separation so that we can accelerate metadata. As many of you know, the majority of storage systems, there's a substantial amount of metadata access, right? Whether for primary application environments or even for backup and recovery. The full suite of data services, snapshots, clones. One of the key things that we have done is a substantial amount of optimization as far as inline compression and dedupe, and we'll have Shailendra dive in a little deeper. To your point, Ray, about the different sets of protocols, Fiber Channel, iSCSI, NFS, CIFS, which is now SMB3, as well as virtual volume support. And then all of that is made available to applications, which is vSphere, Hyper-V, OpenStack, along with what we call IntelliCare, which is our automated call home capability, as well as it does analytics. So we suck data from each of the systems out there, put it up in the cloud, and we got a good perspective of what's going on with the deployed systems in the field.
Do you do analytics in the box, or do you do that offsite?
Great question. We do a combination of both. So for those applications, I mean, for those deployments, we've got analytics that, which is do analytics for data sets that have to be transient, right? And then when we subsequently sort of push the data out into the cloud, we've got substantially more, analytics capabilities.
How do you do it on the box? Do you have like a Hadoop instance or something?
No, we've written our own. We don't use this is not intended for a broad set of analytics. Keep in mind, this is analytics that is tied to the health of the box.
Okay.
What are the different things that are happening?
Right.
How is the, pick up volume, says how is this volume growing? What are the IOPS profiles? Has it changed? If there's been a change in configuration, how is it interacted, right? I mean, how does it change? So that information is available within the box. We've also pulled a lot of that information out into the cloud, which then gives you a perspective that's beyond, let's say, 24 hours.
So you don't actually do analytics on the customer data that is stored on it?
No.
Not on the box, nor on the cloud?
No, we do not do, we're at the end of the day an enterprise storage system. So if you were thinking about analytics through the lens of a Hadoop or something like that, no, we're not doing that. This is about analytics as it pertains to the data and information that we collect from the entire stack.